Hello and welcome to another session in my Data Preparation for Data Science webinar. My name is Gerhard and I'm a book author and data scientist at SAS. Today we are going to focus on data quality for analytics, and I'm going to show you how you can use interactive data analysis to verify the quality of your analysis data. As I'm an enthusiastic sailor at Lake Neusiedl, we are going to use GPS data from a sail race for that case study. One of my passions is sailing and another passion is data science, so I'm very happy in this case study to be able to combine these two areas. You see from the pictures that sometimes I like to sail for fun and for enjoyment, but also sometimes I like to participate in sail races. Let's now have a look at the typical layout of a sail race. Typically, boats start against the wind. So you see here, you have a starting line and boats sail with an approximate angle of 45 degrees against the wind. They are tacking, they're going left, right, tack again in order to reach the bow upwind. Then there's very often a second bow, and finally you go with wind from above down to the starting line, and very often you do this one more round in order to finish the race. In the data that we are analyzing, the layout has been the same, however the wind came from southeast. So we see the layout that I explained earlier on a little bit shifted and tilted down in direction of southeast. So all the data and all the results you're going to see will have rather this layout compared to the layout I showed earlier on. During the sail race on board of our boat, we are using a GPS device from Velocitec, as you can see it here in the picture. So we see while we are sailing the speed and the compass heading. For analysis later on, we can export this data in an XML format, which gives us some metadata about our boat, but more importantly for us, all the track point information on with time, GPS coordinates, heading and speed. And this is what we are going to analyze here in SAS Visual Analytics. So we now jump over to the tool where the data is already loaded, and we are going to analyze it and take a look on what we can find. We have now our data available in SAS Visual Analytics, and we can run our analysis with that. For example, you see we have some measurement variables like heading, longitude or latitude and speed. And we have categorical variables, for example, like team or the time variable of the race. Let's start with the heading variable of the compass heading. If we simply drag and drop this into the analysis, we automatically receive a default display for it, in this case a histogram. From the histogram we see that the values of heading range from 0 up to 360, which makes sense because this is the compass heading. And when we relate this to the logic of the race, we also see that we have had wind approximately from an angle which we see here between 160 and 170. So we see that we have accumulation of heading courses left and right to it, plus minus 45 degrees, which is when the boat sails upwind. And we also have accumulation on the other side, when the wind comes from above and the boat is sailing downwind. So this makes sense. We could say heading is in good shape. This looks like a good data variable. Let's continue to run another analysis and display the race course itself. In order to display the race course itself, we will use a scatter plot. And for this scatter plot, we will go and use the longitude and latitude variables and add them here to the analysis. So as measures, we go and say we would have the longitude and the latitude displayed here. So we see we receive a race course, boats tacking, going upwind, going down. This looks like the data is quite okay. Maybe we should add the color based on the team variable, so to have different lines in different colors per team. Again, from a data quality perspective, we receive the impression that this makes sense what we are seeing here, having boat going upwind, tacking, receiving the upwind bow, and going downwind again. What we also can do here is to add additional rules in order to change the display of the different boats. So for example, we can go and say we would like to use the team variable and use for team number 1 the color yellow. So let's use this yellow for boat number 1, orange for boat number 2, red for boat number 3, green comes with boat number 4, violet boat number 5, and finally blue for boat number 6. This makes sense to do so, as we want to use the boats in many different displays, and we want to make sure that boat number 1 always has the same color when we compare the graphs in different displays. All the other data points which might still be there, we color them black. Now let's say OK, and we see that we now see a very nice shape. We see the yellow line of boat number 1, how they are going upwind. We see the green line of boat number 4 going upwind. We also could consider here the data quality of this display makes sense to us. Let's go one step further, and we know that the data we are having here is longitude and latitude, and you also see that we have here in the objects, for example, we have geomaps. So for example, we could use this also as a geomap. In order to do so, however, we need to define the geolocation variable. We do so by adding a new variable and say we are adding here a geographic item. Geographic item means this is our GPS coordinates. It is based on variable longitude, for example, and we will base this on our latitude and longitude data which we have in our analysis base. So we choose for latitude our lat variable, for longitude we choose our long variable. We say OK, and as soon as we now drag and drop this geography variable into the data, SAS Visual Analytics knows that this is now data which should be displayed on a map, and again we see our race course here in the water, which is a good sign. It makes sense from a data quality perspective if you analyze GPS data from a sail race that all data points lie in the blue area and not outside on land. And we see that this race took place close to the city of Rust in Burgenland, where we see how the boats sailed there. Again, we want to display different colors here per boat, so we just add for the color variable, we choose team. We see that we now get lines in different colors per team. However, this is not the exact color scheme that we just defined here with the other chart. The reason for that is that our rules at the moment just apply to this particular graph. In order to make them available to our entire report, we just push this button to make it a report level display. If we now go back, we see that we also have in this geographic chart colored our teams in the appropriate color to get a deeper insight. So again, another sign, our data looks quite correct, and we see how boats approach the upwind bow differently. Some move more on the left side of the race course, others move more on the right side on the race course, and this looks quite nice. In the next step, let's analyze the speed variable. But maybe before we do so, let's do some housekeeping. It's always a good idea to name our report sheets with some meaningful names in order to be able to detect them and to be able to understand them later on a little bit better. So heading, even if you use short names, that's even always better than just having page 1, 2 or 3. Okay, let's now take a look on the speed variable. Here's our speed variable, and let's drag and drop this in and see how the distribution of speed looks like. Basically, this looks quite nice. We see here speed going from 4 knots up to 10 or 12 knots, which is okay for this boat class we were sailing on, where you can run this speed. However, we also see here quite a big bar of constant values, almost of 2, which is quite surprising. While this looks like a quite natural distribution of the speed during a race, we have a very high constant value of speed 2, which is not really understandable from a business point of view. Let's go and find the reason why this happened and what is associated to a speed value of 2. In order to do so, we could now go and filter and subset and query our data. What are the records that have speed value of 2, and would maybe also find an answer on that. However, with SAS Visual Analytics you have additional options. You also have analytical objects here. For example, what you see here is the decision tree. Let's use a decision tree to explain what can be found in the data, what makes sense to see that speed is sometimes a constant value and on other cases a distribution. So we add as a response variable, we add our speed, and as possible predictors to find out, let's use team, compass heading, longitude, latitude, maybe also the race time that we have captured here in the data, and see whether the tool can find out something for us. We run this and we see that it automatically finds a first split on that, where it tells us that when looking at the splits here, on average we have a speed of 4.8. However, the teams, boat 1, boat 6, are put into one segment, and another segment with a constant value of speed number 2, we have the bows, which have also been inserted into the data in order to be able to display them in the charts. And it looks like that for the bows, a constant value of speed equals 2 knots have been inserted, which does not make really sense for our analysis. It would bias any analysis with the speed variable. So this is something we need to take care of before we run additional analysis and exclude these variables or set them to missing in other analysis. The important point here is that we could, of course, filter and try out by using each variable to see whether there's a relationship with the speed variable. The opportunity that we can use simple analytical methods here allows us to do this automatically, and the data talk to us, and we see just by using decision trees we get an automatic reply. These are the values for the bow. In our next analysis we are going to make use of the interactive features of SAS Visual Analytics. Let's again go back to our race layout. Let's take a copy of that and just duplicate it. And we would now like to analyze this race layout combined with the compass heading data that we have available. So we go back to our variables, take our compass heading data and add them here to receive a distribution view on that. However, this is maybe not as nice as we would like to see it, so we better change this not to a vertical but rather to a horizontal one. And from the ordering, we do not want to order them by frequency but by compass heading. So this makes much more sense now, and make this a little bit smaller. So we see we have compass headings here in the area, for example, of 119, which is the upwind course on the left side, the upwind course on the right side, and here we have the downwind courses when the boats go back to the starting line. In order now to combine this compass heading with the race layout, we can do the following. We can say, we set some actions, and we would say automatically combine these two graphs and create a linked selection. A linked selection means if we now select here certain data points, so for example these ones, we see that we get a selection here on the graph where these data points are lying on the race field. So it is now very easy to verify our data. If boats are going to the left on the race field, if we are capturing this here with the mouse, we receive an interactive selection of these data points on our race field. This makes sense, so we can verify if certain compass headings occur, for example, boats going to the left from the compass heading or boats going to the right on the compass heading. We expect only certain sections being displayed here on the race field. This makes sense from a business point of view. If you do race sailing, you understand that these fields should only be here on one or on the other side. What we also see, if boats are going downwind, for example these ones here, we have the data being selected here after the upwind bow. Boats are going downwind with compass headings like 350, 355 up to 360, and of course also on the other side starting with 0 and 1. So if we select these ones, we again get our values selected here. Boats are going downwind. However, surprisingly, what we also see if we select the compass course 1, 2, 0, 1, 2 and 3, which means boats are going north, so which is definitely the downwind course in this race, we also see some selected data points here where boats are going upwind. So if we zoom in here, we see what is quite surprising. The boat is going upwind with a compass heading of 127, 130 on average, and then we have one data point where the heading is only between 1 and 2, which would mean that for 2 seconds the boat is just turning north, and within the next 2 seconds boat is turning south again, which is technically and physically definitely impossible. It looks like we have some data quality problems here, that on some elements of the race course we have wrong compass headings, and this is something we would like to investigate in more detail and to find out the reason for that. We now want to find out whether there is a pattern in the data, whether this only occurs at certain points in time or only for selected teams or only on certain sections of the race. In order to do so, we go and create a sequence chart into our analysis. We add a new page, say we would like to see here a scatter plot, and in this scatter plot we add as the variables here, we are adding the compass heading which we have, which is here the heading variable, plus the sequence variable, which is an enumeration of each GPS data point in our data. After we have done so, we see that here for each team the race starts at data point 0 going up until the end of the race. And we see the distribution of the compass heading. So we have a very similar view of what we've seen before. Boats are going upwind, either sailing to the left or sailing to the right. And then as soon as they reach the upwind bow, boats are going in direction almost north until they reach the goal. Let's add here also as a color our team variable again, so we can display this more nicely. Maybe for a better display we reduce a little bit our marker size to a little bit smaller one and increase the transparency in order to see also the other groups of boats. We still remember that we have the bows in the data, so maybe we want to get rid of them or erase them here from our analysis. We can easily do so by filtering, adding a filter variable, for example, for team, and say we do not want to display the bows 1, 2 and 3 and only have the data points that we have here in our. Let's go and filter our analysis per team, per boat which is participating, and in order to do so we create here some room in order to add filter here, add the team to that, and change this team display to a button bar because it's easier to select then. And we see that we get our boats 1 to 6 which we can select here. So if we, for example, select boat number 1, we see a subset of our sequences for boat number 1. It started on this side, tagged, went to the other side, came back, and so on. But we see that these very surprising data points at heading 2, boat going north while being on a south wind course, happens almost for all boats, happens almost at the any time of the race, and also happens both for the left and for the right side of the race. So there's not real a meaningful pattern which we can find here. Let's quickly add the race time variable to our data tip values. So when we touch a point to see the time of the race in order to identify the data points easier. So we have this now. If we, for example, take a look at this data point, we see that this surprising compass heading of 1.98 happened at 2 hours, 4 minutes, 50 seconds in our data. Let's now go to the source data and find this data point to check what's really happening there and whether and how this data point has been recorded. I've opened here the source data that we downloaded from our GPS device for the sail race, and I can go here and search for the point in the data that we're looking after at 2 p.m. 4 minutes 50 seconds. If we search for that, we find here this first record for team number 1, and we see that the compass heading is recorded here correctly. It is 198 degrees. However, there is no decimal point and no values after the decimal point, as it was 0.00. It looks like that the GPS device outputs the data just as integer numbers in case it's 0.00. However, it looks like our data integration job was working badly here because it forced two values after the decimal point and shifted our data artificially to a value like this. So what we find here is a big problem in our data loading job, as it changes the data and reformats them and changes the value range. And this is something which we only found out by analyzing the data in a visual way, by connecting different graphs and different layouts and working with business knowledge We know how a sail race looks like. We have some expected values for the compass heading during a race on different sections, and this was the reason how we could find this value, and we have a trigger that we now need to change our data integration job. Again, this is a very important example because from a technical point of view, this data was most likely right. The compass heading was between 0 and 360. Also the layout of the course, of the race course, was fine. However, as soon as we analyzed them in combination and analyzed them interactively, we were able to find data quality problems in the data. This is a very good example how important it is to combine business knowledge and interactive analysis to browse your analysis data. From this case study, we have seen that it's important to be able to touch the data and to be in the middle of the data to find certain data quality problems. We have seen that with interactive data analysis, we were able to find some problems in the data, like those with the wrong data transfer of the compass headings, which might have been unseen and undiscovered otherwise. As we were able to compare this data in different scenarios interactively, we were able to uncover that. The nice thing here is also that not only a data scientist who can program SQL code, SAS code or Python code can do this, but also a data scientist who has some business background and just wants to work with the data from a visual perspective, can analyze the data and can find important things. We have also seen with the decision tree that analytic methods help us to discover certain data quality problems and especially reasons for these data quality problems, like we did for the speed variable. I have summarized this example and many other examples in my Data Quality for Analytics book, and I'm happy to discuss additional topics in future webinars as well. Today, we have touched the Data Quality for Analytics case study. In my data preparation for data science webinars, I'm also talking about how you can assemble your data for the analysis or how you can derive features out of the data in order to feed your analytical models. In my books and in my work around data science, I'm always combining the ideas of preparing data, data quality checking, and how you can use data science methods to answer business questions, and how this is all interleaved and combined. You can find more about these topics in Medium articles and LinkedIn. I'm regularly publishing webinars on YouTube, publishing articles on SAS communities, and all my programs are available on GitHub. Thanks a lot for joining, and look forward to talk to you soon in a future webinar.